Hello, welcome. This is for class on November 5th or 6th, so Thursday, Friday. The homework that was due was the types of which air pollutant. And I had a quick check-in about election thoughts. So today we went over the concepts of acid rain. So people did an assignment that as group work, investigating acid rain. And then there is homework, of course, too. So if you missed class, you have an acid rain assignment to do, as well as the homework that I assigned. So cool. My do now is, what do you think of when you hear the term acid rain? And people put a lot of different answers, such as they think of sulfur dioxide and nitrous oxides. They also think of how it's bad for the environment and in what ways, if it burns. So today we centered class around the question of how has the acid rain problem in the US changed over the last 30 years, because it has changed a lot. So I gave the class these two data sets to look at, and then I wanted them to write one observation about the data and one question. So look at the data. Some people talked about how clearly that there is less of an acid rain problem now in 2016 as opposed to in 1985, where it was an issue. They also noted that on the East Coast, there was much more acid rain on the East Coast than there was on the West Coast. That was an awesome observation as well. And then a question about the data, some people asked a question like, how much is 4.0 pH? How did the acid rain become less in 2016? So those are great questions that we'll hopefully answer today. In class, I reviewed real quick the pH scale and like the concept of acids and bases, just in case we need a refresher for Mr. Fields' class. So in the pH scale, it's literally just the measure of hydrogen ions. And hydrogen ions is just a hydrogen atom. So where you are on the acid base scale depends on the concentration of ions. So this is the pH scale, which you've probably seen before. Of course, neutral is just water with nothing else in it. As the substance becomes more acidic, it decreases in number. So like 1 is the most acidic as opposed to 14, which is the most basic. Now this is where things get a little bit trickier to wrap your head around. The acidic side, although the number associated with it on the pH scale is smaller, there's actually a higher concentration of hydrogen ions. That's something to think about. On the other hand, you have higher numbers when it's basic on the pH scale, but it has a lower concentration of hydrogen ions, meaning it has less hydrogen ions in it. Okay, so it's almost like opposite a little bit. Okay, so that's the pH scale. You got like the lemon juice over here where it's really acidic, and then you got like hand soap and ammonia and bleach over here where it is more basic. All right, so with that in mind, oh, and of course that, if you guys were wondering in this map, see how the red is more acidic because the number is smaller than on the pH scale, while the green have like a higher number, which means it is less acidic. So hopefully that makes sense a little bit. Okay, so in class I took time to explain how acid rain forms. So this is gonna be kind of like an ozone explanation. So bear with me, this is like the chemistry behind acid rain. Okay, so when we remember sulfur dioxide, which is a primary pollutant, which means it comes from like cars and factories and the burning of fossil fuels. And so those get released directly into the atmosphere. Now, once it's in the atmosphere, it mixes with the things in the atmosphere, right? And so the atmosphere has oxygen, obviously, and it also, the sun acts as, is important because it breaks apart bonds that these molecules have. So what happens is it's sulfur dioxide is then maybe the oxygen and the sulfur, they separate, so they're no longer a molecule and they mix with the oxygen. So what happens is these atoms kind of are able to recombine into a different configuration in the atmosphere, and oftentimes they'll become sulfur trioxide. So this is just a different molecule. Okay, so now instead of having 2 oxygens, as it did when it was first released in the atmosphere, it now has 3 oxygens, right? And a sulfur attached. Okay, so with the sulfur trioxide, which looks like this in molecule form, now the sulfur trioxide is floating around the atmosphere. And again, the sun degrades it and breaks up the bonds again. And then there's also water in the atmosphere, right? And water, just like all of these other molecules, also break apart. And so then they recombine again, just as the sulfur dioxide and oxygen did. Water and sulfur trioxide bonds are going to be broken and recombine. And so then it has an opportunity to turn into sulfuric acid, which is a primary pollutant. So you see the hydrogen, it got broken off from the water, and maybe it recombined over here, as well as the oxygen did as well. All right, so now there's sulfuric acid. Remember, the hydrogen ions itself are what determines on the pH scale where it is. So now you have hydrogen ions attached, and so it's an acid. And then that acid mixes with with more water to become rain, and it rains down on us. So I asked students to use the explanation that I just gave about acid rain, and then in the pear deck they answered in their own words, how does acid rain form? And what more do you need to know to understand how acid rain has changed in the past 30 years? So now that we know this, what else do we need to know in order to answer our big overarching question of how acid rain has changed in the past 30 years? So they gave, so everyone was able to try to use this vocabulary and answer the question. So then I explained the group work, which for those that missed it, you will have to do this on your own. So the group work, the goal was by the end of class, you'll be expected to write a paragraph that explains how acid rain has changed in the country over the past 30 years. And it must include the following details of what caused the acid rain problem in the first place. Why was it worse in some places than others? So why was it red in the East Coast rather than just all of the US? What is happening to acid rain over time and why? Okay, so the way that it's going to go down is each group has a document. So it'd be, each of you will have a document that is a table of clues, and then you have to write the information that you learned from each clue, and then what else you need to know after this clue in order to answer the question. So you do that on your own, and in the document I've linked you 10, actually I think it's 9 different clues now. So I've linked you 9 different clues. And then you have to go through with all 10, after you've gone through the table and answered all 10 of the clues, you want to write a paragraph that answers these questions. So the paragraph should be like 4 to 6 sentences long. All right, so let me show you the document. You should find the document under classwork, and it should be assigned just to you. And so you open up the document that says acid rain investigation. So first, there's the goal, is to answer this question. So how has the acid rain problem in the US changed over the last 30 years? So in the document, the first document I've linked is just a PDF of the phenomenon, which is the fact that In 1985, this is what the map of the US looked like in terms of acid rain. And over time, you can scroll through year by year to find that the acid rain issue has actually started getting better. And by 1916, this is what it looks like. All right, so that document's available to you to look at. The second document is the list of acid rain clues as to how to answer this question. So you see here that I've given you a bunch of different clues. Oops, it's still loading. For you, and each clue, you're gonna go into your document here and you're gonna write, what did you learn from clue number 1? So this clue here, what did you learn from that? Okay, now that you've learned this from clue number 1, what else do you need to know next? So that is another thing, that's what you should write here. And you're gonna do that for each clue. And at the very end, you're gonna write a paragraph, just as I said before. And you're gonna include these words. All right. So that's what we did in class. If you missed class, you are responsible for that on your own as homework. So in addition to that, your homework, there is a photochemical smog investigation. So you investigated acid rain, which is a really important secondary pollutant for us to know. And then the other secondary pollutant that's also really important is photochemical smog, which is otherwise known as low-level ozone. So it's an article. So I want you to read the article and answer the attached questions. And that is due either Sunday or Monday, depending on which class you have. All right, so the photochemical smog is in your Google Classroom here. And then also I have attached above the photochemical smog investigation, I've also attached all of the documents that your classmates finished in class. So you can take a look at that if you feel really lost. All right. Okay, so that is all I have for you today. So please, please, please finish those 2 documents and it'll prepare you for the assessment. All right. Thank you.